Hi, I'm Dr. Andrew Brandeis. Welcome to part 1 of the intestinal repair protocol. The first thing to understand is what is the gut? We're going to use this term a lot, and I want you to understand it. Basically, the gut is a tube that connects your mouth to your anus. And as disgusting as that sounds, it's totally true. So I want to take you on a journey of what food experiences as it travels on this path. So you can see in this picture here, at the top here, it's showing you the salivary glands, and of course those are part of the mouth. And this is where food is physically broken down into smaller, easy to digest particles. And most importantly, food is mixed with enzymes that starts to help break down carbohydrates. So chewing your food is actually the first step of important digestion. The other thing that happens when you're chewing your food is that the brain tells the stomach that there's food coming, so it should start to release chemicals and hormones that will prepare it for the arrival of this food. In the stomach is where food gets mixed with acid, and acid will really do a good job of breaking down proteins into amino acids so that you can easily absorb them. And to sort of, understand what that looks like, imagine throwing a piece of chicken in a glass of water versus in a glass of vinegar. In one, it's obviously going to break down a lot faster. And that's what you want happening in your stomach. So the stomach's a muscle, and it's physically sort of moving to compress the food and mix all the acid around with the food. From there, food will travel into your small intestine. And the small intestine is actually pretty long. It's, in some people, 20 to 30 feet long. And it's broken up into 3 distinct parts. And I want to talk for a second about the first part of the intestines because it's really important. You've probably heard about the pancreas. This is where the pancreas actually has a couple of functions, but this is where the pancreas will dump what's called bicarbonate into the intestines. And bicarbonate, what it does is it sort of counteracts the acid so that the acid from your stomach isn't coming and burning a hole through your intestines. So it's the food is mixed with bicarbonate and it becomes more neutral so that it is gentle on all the cells and bacteria that live in your intestines. The middle and the end of the small intestines is where most nutrients are absorbed into the body. So you've got 30 feet of intestine where bacteria can do a really good job of breaking down food into smaller, more manageable pieces for them to then absorb and send into the body. It's important to understand this tube of the gut as outside of the body. So what I mean is you've got bacteria digesting your food so that you can absorb it into the bloodstream. When food is in that space, in the intestines, it's technically not part of your body. And that's not such an important concept to understand, but it's one that I think is interesting. And lastly is the colon. And this is where most of the water gets reabsorbed from the food into the body. The colon's pretty short. It's only about 4 to 6 feet long. And what it does is it helps to form the stool that will then be eliminated out of the anus. And this is stool, as you know, is unused foodstuffs, toxins that your liver may have detoxified. Stool gets its brown color from dead red blood cells, which your body is turning over every few months. And mostly you think of this as just waste exiting the body. So that's a good overview of the gut. And I want to show you here a cross-section of the intestine. And I just want to do this to sort of orient you to what we're going to be looking at next. So imagine this is a slice of the tube of the small intestine. And you can see sort of in the center of this tube, there's all these folds. And those folds, they're called villi, and they're there to increase surface area. Increasing surface area is important to increase the area that you could absorb nutrients. So all these villi are really important to healthy intestinal function. And what we're going to do now is zoom in on a really small part of one of those villi. And here what we're looking at is you've got these cells in the center that are in yellow. And you can see that there's like little finger-like projections on top of those, and those are called microvilli. So sort of to orient you here, on the bottom of the screen would be inside the body, and on the top of the screen would be this mucosal layer where the food is that's that what I call outside the body. These cells that are in the center of the screen, those are sort of lining one of those villi that I showed you in the screen before, and they have their microvilli on them to further increase surface area for absorption. So what's important here in this picture is that you see that there's like a bunch of bacteria living in the mucus in the top, and in the bottom you've got parts of your immune system that are, you see this purple cell is literally sticking a finger out into the outside world to take a sample of the environment and see what's going on there, and then come back in and signal this B cell at the bottom of the screen, which is another part of the immune system, and say, hey, there's an infection here, let's launch an attack. So you don't need to understand the biochemistry of this, or the physiology, but it's important to know that there's a lot going on right at this border where the outside world meets the inside world. And this is where nutrients are absorbed. So you can imagine that if there's damage, if the war goes on and there's damage to these cells, there's going to be problems absorbing nutrients. Okay, here is a slide, a histology slide, and what's important about this is that on the left you see the villi that I showed you in the earlier screen, and these villi are really interesting. So this is where I had mentioned earlier that there's this like mucus layer sort of at the top of the screen, and at the bottom of the screen is inside the body. On the right-hand side of the screen is the same patient 2 weeks after being exposed to gluten, and this is in a gluten-sensitive individual. Not everybody's gluten-sensitive, but in this particular person, you can see how quickly there's dramatic change. All those villi are gone, and they're replaced with, well, inflammation is what changed this scenario here. So the only reason I'm showing you this isn't to scare you off of gluten, but to show you that the food that you eat can have dramatic impact on the physiology of your gut, which is going to lead to problems that we need to solve. So here's just a cartoon. These bacteria complaining that it's overcrowded in the gut. And the reason I'm showing you this is because the intestinal tract is a very sensitive ecosystem. It's called the microbiome. And it's susceptible to damage from a variety of factors. There's all kinds of bacteria that inhabit the gut and serve beneficial functions, including not only regulating acid, but digesting your food, aiding in absorption of nutrients, assisting the immune system. I mean, the list goes on. In fact, there's 10 times more bacterial cells living in you and on you than human cells. So if you're sitting in a chair right now, you are at least 10 times more bacteria than human sitting in that chair. So you want to treat your bacteria well. You want to take care of them. Healthy intestines also have small amounts of bad or pathogenic bacteria, or even yeast and fungus or parasites that are living in there. And as with any ecosystem, there needs to be a balance for it to be sustainable. And if things get out of balance, it can have devastating downstream effects. And if you're watching this video, chances are your microbiome is compromised. So here's just another picture to show you that different parts of the body really have various ecosystems going on that are important. You know, I think more and more these days we're seeing parents sort of bleaching countertops and everything that their kids might touch. And the problem is that you're actually removing potentially good, healthy bacteria that we've evolved with over hundreds of thousands of years. So you should start to think of your microbiome as a really good friend that you want to take very good care of. And in a further video, I'm going to show you exactly how to do that. So that's part one of the intestinal repair protocol. We'll move on next to part two, where we discuss intestinal diseases.